Hello everyone, welcome back to my YouTube channel Learn Mathematics. This is Rekha Chabra, your maths teacher. I hope you all are doing great and utilizing your time in a good way. Please like, share and subscribe this channel if still not done. And don't forget to comment after watching the complete video. Students, practice makes a man perfect. So let's practice one more time in this revision video 3 of chapter number 1 sets. So let's start. Question number 1. Write the following sets in the roster form. I hope you must be knowing what is the roster form. Whenever we have to write down any set in the roster form, it means we have to list all the elements and we have to separate them by using comma. First part says A is equal to X such that X belongs to real number and satisfies this equation. So solve this equation, and after solving we are getting X equal to 2. So A is equal to a singleton set 2. Second part, b is equal to x such that x square equal to x and x belongs to again real numbers. So after solving this given equation x square equal to x, we are getting x equal to 0 and 1. So b is equal to 0 comma 1. Third part, c is equal to x such that x is a positive factor of prime number p. Since positive factors of a prime numbers are 1 and the number itself, so it means c is equal to 1 comma p. Second question, here also we have to write down in the roster form. First part is exactly the same as we just discussed on the last slide, so I'm not going to discuss. Please you try yourself. Second part, E is equal to W such that W minus 2 upon W plus 3 is equal to 3, and this also belongs to real numbers. So here what we have to do, again we have to solve the given equation, and after solving whatever value we get like minus 11 by 2, this is set E, again a singleton set. Third part also, students, please try yourself here. First of all, you have to reduce the given equation into a quadratic equation by assuming x square equal to y or some other variable. Third question, in a class of 60 students means total students are 60. Number of students, let's denote with letter U, is equal to 60. 25 students play cricket. Let C be the set of students, those who play cricket. It is 25. 20 students play tennis. Let T be the set of students who play tennis. So T is equal to 20. And 10 students play both the games, means their intersection, common students. Find the number of students who play neither. So the number of students who does not play any of these games is equal to total students minus the ones who play cricket plus tennis minus both. So it is 25. Fourth question, state which of the following statements are true and which are false, and then we have to justify our answer. First part says 35 belongs to this set X, where X has exactly 4 positive factors. So let's check the factors of 35. Factors of 35 are 1, 5, 7 and 35. So 35 is definitely an element of the given set and the statement is true. Second part, 128 belongs to this set Y. The sum of all positive factors of Y is 2Y. First of all, let's talk about the factors of 128. These are all the factors of 128. Now, sum of all the factors, sum of all positive factors. So, let's find the sum of all the factors. It is 255. It is equal to 2y. So 2 into y means 2 into 128. This is 256. So they both are not equal. So the given statement is false. It is not true. Third part, please try yourself. Fifth question, given set L, M and N, and we have to verify this thing. So let's talk about left hand side first of all. First of all, let's calculate M union N. So M union N means we have to list all the elements of M and N, and common elements we have to take only once. So 1, 3, 4, 5 and 6. 1, 3, 4, 5 and 6. Now L minus this set. So now we have to subtract the common elements of set L and set M union N from set L. So what are the common elements? The common elements are 1, then common element is 3, and then common element is 4. So we have to subtract all these common elements from set L. So only one single element will be left out, which is 2. Now let's move on to right hand side. Let's calculate L minus M. It means we have to subtract the common elements of L and M from set L. So what are the common elements? First common element is 3 and next is 4. So when we will subtract 3 and 4 from set L, so it will be 1 and 2. Then let's calculate L minus N. What are the common elements in L and N? 1 is common and then 3 is common. So 2 and 4. Now we have to find out their intersection. Intersection means the common elements. So the common elements in these two sets is only one element, which is 2. So left hand side is equal to right hand side. Sixth question, given that n is equal to 1, 2, 3 natural numbers 1 to 100, then write down the subset of n whose elements are even numbers. We know the even numbers, so subset of n whose elements are even numbers is equal to 2, 4, 6, 8 up to 100. Another one is whose elements are perfect square numbers. So let's start with 1 and let's go up to 100. I hope you all know what is the meaning of perfect square number. So these are the perfect square numbers. Seventh question, if x is this set and if n represents any member of x, then write the following sets containing all numbers represented by 4n. 4n, what is n? N is the member of this set. It means n can take values 1, 2 and 3. So if n is 1, the answer is 4. If n is 2, the answer is 8. And if n is 3, so the answer is 12. So 4, 8 and 12. This is first set. Second is n plus 6. So if n is 1, answer is 7. If n is 2, it will be 2 plus 6, 8. And if n is 3, 3 plus 6, 9. So 7, 8 and 9. Third and fourth part, students, please try yourself. Eighth question, if y is equal to 1 to 10 and a represent any element of y, write the following sets containing all the elements satisfying the given conditions. First part says a belongs to y, but a square does not belong to y. It means if the element is in this set, its square should not be in this set. So let's talk about 1. Let's start with element 1. 1 is there and 1 square is 1 only, that is also there. So 1 is not allowed. 2 is here, 2 square is 4, that is also there. So 2 is also not allowed. Let's talk about 3. 3 is here and 3 square 9. 9 is also there in this set. So it means 1, 2 and 3 are not allowed as per the given condition. And we can consider rest of the elements like 4, 5, 6, 7, 8, 9 and 10. Second part says a plus 1 equal to 6 and a belongs to this set y. Now which element of set y can make this statement true? So there is only one single element 5 which can make this statement true. So answer is only 5. Third part, please try yourself. Ninth question is based on Venn diagram. A, B and C are the subsets of universal set and A, B and C are given and U is the set of all whole numbers. You know very well that universal set we represent with the help of a square or a rectangle and sets we represent with the help of circles. Now A, B and C are these three sets. Let's find out which are the common elements. So 2, 4 and 8 we will write here. Now 6 and 12, these two elements are common in A and B. So we will write here on the common region. 20 is common with set C. So we will write here in the common region of A and C. Now rest of the elements of B we will write here 3 and 9. 15 is common in B and C as well. So we will write here on the common region of B and C. And 5 and 10 we will write here and 15 is common with set B, so it has already come here. 20 was common with set A, so it has already written here. So this is the Venn diagram representation of the given sets. Question number 10. Very good question. Two finite sets have m and n elements. The number of subsets of the first set is 1, 1, 2 more than that of second set. The values of m and n are respectively a, b, c and d. Four parts, four options are given. Let's find out. I hope you must be knowing what is the formula to calculate the number of subsets. Yes, the formula is 2 raised to the power number of elements of that set. And they are saying the two finite sets have m and n elements. And the number of subsets of the first set is 1, 1, 2 more than that of second. So this is, let's say, first set 2 raised to the power m minus 2 raised to the power n is equal to 112 according to the question as per the given condition. Now what we can do in the first term, we can add n and we can subtract n in the power. And after adding and subtracting, what we added, we have taken it common. 2 raised to the power n common. And what we subtracted will be left here in the first term. 2 raised to the power m minus n minus this is common is equal to 112 can be written like this, 2 raised to the power 4 into 7. Now on comparing 2 raised to the power n with 2 raised to the power 4, they are equal and this term is equal to 7. Now if the bases are same, it means their powers are also equal. So n is equal to 4 and here 2 raised to the power m minus n is equal to 8. This minus 1 will be shifted to right hand side. Now 8 can be written as 2 raised to the power 3. Again the bases are same. So m minus n is equal to 3. N we have already calculated, that is 4. So m is equal to 7. So which is the correct option? B is the correct option, 7 comma 4. So students, I hope you must have understood these questions and few parts I left for you. So please try those questions yourself and don't forget to write your name, class and section in the comment box. Thank you very much.